Today's lesson is over section 3.3, where we'll be talking about derivatives of trigonometric functions. Now, like first couple slides here, I have the proofs of what the derivative of sine, cosine, and tangent are. These are not things you have to be able to reproduce or be able to find on your own. I'm just showing you how they come about so that you understand how I got them. So looking at this one, the derivative of sine is cosine. Now doing these proofs, I'm using the definition of a limit for a derivative to help me figure these out. I'm also using some trig identities like the addition of two angles for cosine and sine. Also note that I am factoring things out and I'm getting to a certain part where it's a limit of cosine of h minus 1 over h and sine of h over h, as the limit is going to 0 for that one as well. And using the graphs, I'm able to show that those are 0 and 1. For the derivative of tangent, I just use the quotient rule since I already have the derivatives of sine and cosine at my disposal. And then using some other trig identities, I can show that it's secant squared. Now this next slide is the one you really want to be able to copy all this stuff down. So I have all 6 trig functions and their derivatives. So I already showed sine is cosine. For cosine, it's negative sine. For tangent, it's secant squared. But for cosecant, it's negative cosecant times cotangent. For secant, it's secant times tangent, and for cotangent, it's negative cosecant squared. One of the neat things about sine and cosine is that it repeats. So if we start with sine, the derivative of sine is cosine, then cosine is negative sine, then derivative of negative sine is negative cosine, then for negative cosine, it's sine again. So they kind of repeat. And notice at the bottom of that, I have those other two limits that we found in their derivatives. Now for example 1, for these with the trig functions, you're kind of use like power rule, quotient rule, and product rule at your disposal, just with trig functions intermixed. So I take the derivative of the top, which is 1 minus secant x. So that would be negative secant x times tangent of x. So the 1 goes away, but the negative stays there. And then times the bottom. And then the derivative of the bottom is secant squared times the top, and then the denominator squared. And then from there, I want to kind of simplify a little bit, so I multiply those first two terms together, and then I distribute the negative secant squared through to the 1 minus secant. And then from there, I can take out a negative secant x. That allows me to kind of maybe use some of my other trig identities. And so I see that tangent squared and negative secant squared are there. And so I can maybe manipulate this. So I see that secant squared, and I know that that is 1 plus tangent squared. So I'm going to actually take that out, and I'm going to insert in 1 plus tangent squared in its place. Then from there, I should be able to distribute that negative through to make it negative 1, and then a negative tangent squared. That allows me to cancel out the tangents, and then I'm able to have just negative secant of x times secant of x minus 1, all divided by tangent squared of x is my final answer. Also know that there's not just one way of doing these. Like you can use the Pythagorean identities in different ways to be able to get the same answer. For letter B, I need to use the product rule. So even though there's a 3 in front, just have that attached to one of those functions. So either cosecant and tangent. I used it with cosecant, so that's how I got negative 3 cosecant times cotangent, and then times tangent plus the derivative of tangent, which is secant squared, times 3 cosecant. Then from there, I'm just factoring out what I see or what they have in common. So I see that they have a 3 cosecant in common, so that leaves me with negative cotangent times tangent plus secant squared. And then remember your ratios or your different reciprocal identities. So cotangent is the same thing as cosine over sine. Tangent is the same thing of sine over cosine. So they actually crisscross each other out, leaving you with negative 1 in that spot. And then negative 1 plus secant squared of x is actually the same thing as tangent squared. So I'm going to insert that in, and that gives me the answer of 3 cosecant of x times tangent squared of x. Now for example 2, it says a weight oscillates on a spring. Its vertical displacement in centimeters at time t seconds is given by the position function of negative 2 cosine of t. So letter A wants me to find the position, velocity, and acceleration of the weight at the time of 5 pi over 3 seconds. So since I'm given the position function, all I need to do for the first p's is to just plug in 5 pi over 3 into the function that I'm given. And so here you're going to have to use your unit circle values again. So -2 times cosine of 5 pi over 3. Since 5 pi over 3 is in the fourth quadrant, that gives me the value of 1/2. And so -2 times 1/2 gives me -1 centimeters. Then to find the velocity, I need to take the derivative of my position, which cosine's derivative is negative sine. So -2 times negative sine gives me 2 sine of t. And then do the same thing as I did for the position. So I'll plug in 5 pi over 3. And sine at 5 pi over 3 would be -√3 over 2, since it's in the fourth quadrant. And so the 2's cancel out, leaving you with -√3 centimeters per second. So then I take the derivative of the velocity function to get my acceleration. So the derivative of negative, or sine of t, is cosine of t. So that gives me 2 cosine of t for my function, and then do the same thing. Now, since we already used cosine of 5 pi over 3, we know it's 1/2. So 2 times 1/2 gets me the value of 1. So this would be 1 centimeter second squared. And for the last question here, it says, at the moment that we've been talking about for part A, in what direction is the weight moving, and is it speeding up or slowing down? So to determine which direction it's moving, we look at the velocity at that moment. And so it has a negative velocity, so that means the weight is moving downward, since we're talking about vertical displacement, so up or down. Up would be positive, down would be negative. And then for the last piece of that, is it speeding up or slowing down? So remember, that means that if it's speeding up, the acceleration and velocity have the same sign at that point, and slowing down would mean they have opposite signs at that point. So in this case, it's slowing down because the velocity is negative and the acceleration is positive. Okay, have fun.